Free response number 2 says use the partial fraction technique to evaluate the integral. It gives you 1 over x times x squared plus 1 quantity squared. So this does look like a perfect partial fraction problem. So let's go ahead and write out the partial fraction decomposition and see what we can do. So in this case, I note that there is an independent linear root and there is a repeated quadratic irreducible root. So when I write it out, I write out as a over x, so that term is taken care of. I have a quadratic, so I need to write a linear term on top. And because I'm repeating the root, I want to write another linear root, but with x squared plus 1 quantity squared. Okay. So now we have the terms written out. All we need to do is figure out what a through e actually are. So it's important to point out that with a, I can just do cover-up method. So any kind of linear root like that, just do cover-up method, saves yourself a little bit of time. So with that, I'm going to set this equal to x squared plus 1 quantity squared. So when I do cover-up method on that, I'm plugging in x equals 0. If I cover this up and cover this up, all the other terms drop out. And when I plug in x equals 0, I end up with a is equal to 1. So we've already solved for one of our terms right away. So that's good. That saves us a little bit of time in the long run. Now, I need to kind of make a choice. I have B, C, D, and E, and I need to solve for all of them to get a final answer. So the way I'm going to do it is I'm going to go ahead and write out my system of equations, solve them, and try to figure out what B through E are. Now, the fact that we already know A helps us a little bit in the long run, but it is still going to be some work. And regardless of how you do it, you could also just plug in a bunch of different x values to try to get it. But keep in mind, there are 4 unknowns in this case, so you need to come up with at least 4 equations. And if you start using really weird numbers to plug in and solve it, you're going to end up with some weird equations, and it's going to take a lot of math to try to get through it. Not that my method is going to require any less math, but I feel like it's a little bit more compact and a little bit easier to use, because this is stuff you've done in class. It's just now, with a repeated quadratic root, it gets a lot harder. So what I'm going to do is I'm going to get common denominators for all of my terms. So I have 1 over x squared plus 1 quantity squared. Now for my a term, I need to multiply by an x squared plus 1 quantity squared, and that's equal to, so I already know what a is. I'm just going to cross that off and write 1. So this first term would be x squared plus 1 quantity squared. That's all over x squared plus 1 quantity squared. Again, you have to multiply by 1 to get a common denominator. That's plus, so bx plus c, I don't know what those are, so I have to leave those alone. But to get a common denominator, I have to multiply by x and x squared plus 1. And that's all over x squared plus 1 quantity squared. dx plus e, a little bit easier. This is just as simple as multiplying by x to get x squared plus 1 quantity squared. Okay, good. So we've got everything down. Now comes the hard part. We have to go through the math. So we have all of the denominators cancel out, and we're just left with everything on top to create our system of equations. So I have a 1 is equal to x squared plus 1 quantity squared. Which actually what I'm going to do is I'm going to go ahead and work out what that is. So to figure out what that is, I just have to FOIL it out. X squared plus 1 quantity squared becomes x to the 4th plus 2x squared plus 1. bx plus c, that's going to be a little bit harder. I'm going to do that in a couple different stages. Actually, I'll do it over here to the side. So bx plus c times x is just bx squared plus cx. And that's times x squared plus 1. So what that requires me to do is I have to FOIL that term out. I end up getting bx to the 4th plus bx squared plus cx cubed plus cx. So that's what I'm going to write here. Cubed plus cx. And now to compensate for this last term, that's pretty straightforward. I just end up getting dx squared plus e to the x. So I now have my entire equation. And remember, everything over here needs to equal what's over here. And what makes this problem a little bit simpler is that there's only a constant. So that means that when I start adding all these x to the fourth, x squared, x cubed terms together, they have to equal 0 on this other hand side. Now that doesn't mean that a, b, c, and d, and e are going to necessarily be 0, but altogether this needs to cancel out and I need to just be left with a 1, which looks like it's this term here. So let's go ahead and start grouping the terms together. So if I group together my x to the fourth terms, I have 0, there's no x to the fourth term on this side, is equal to 1, there's an x to the fourth right here, and plus b. And there's no other x to the fourth terms in that case. So what that tells me is that from this equation, b is equal to -1. Okay? I have an x cubed term, and c is the only x cubed term I see. So if there's no term over here, and I set it equal to c, c is just equal to 0. So that tells me that c is 0, b is -1. So we've gotten that so far. Same thing with d, so I have 0 is equal to, I have a 2 here, I have a plus b, so that cancels out that cancels out that, and I have a plus d. I know what b is -1, so that tells me that 2 minus 1 is equal to 1, d is equal to -1. So this is equal to -1, and e, I have a c, so I have 0 is equal to c plus e, it looks like. C is 0 plus e, so e is also equal to 0 as well. So this term drops out. Okay, so now I've gone through, I've figured out all my terms, a through e. A little bit of a painstaking process, but we've appeared to have arrived at a pretty good answer. So now what I can do is I can go ahead and write down my new integral. So I'm going to be integrating 1 over x dx minus the integral of x over x squared plus 1 dx. B was -1, c was 0, so I don't need to include another integral for that c equals 0 term. And then I have minus x over x squared plus 1 quantity squared dx. And e was 0, so we don't include that. So now all I need to do is I just need to go through, figure out how to integrate this term. Well, let's go ahead and clear ourselves some room here. So I'm going to go ahead and erase this stuff, because we've already figured out what a through e are, so we don't really need to work anymore. So now I can integrate this first term. 1 over x dx is ln of x. So I know what that is. So we've got that down. Now I need to figure out what I'm going to do for here. Well, what it looks like I can do is I have an x squared plus 1 and I have an x, so I can actually make a u substitution. So if I do u equals x squared plus 1, du is equal to 2x dx. Neither of these have a 2 in them, so I'm going to go through and just divide that 2. The good thing about this, though, is it looks like we're going to have to integrate them independently of one another, and we can't really combine them, nor would we want to combine them. We just spent all this time splitting them. What it looks like we can do, though, is we can use the same substitution. It's just going to come out to different results. So that saves us a little bit of time in general. So I'm going to go through and plug in for this integral with my terms. I end up with du over u. And here I end up with minus 1/2 integral du over u squared. So now I just go through and I integrate these terms. So this is equal to -1/2 natural log of u plus 1/2 1 over u. So when I integrate du over u squared, I end up getting -1 over u. That negative and that negative cancel out, and I'm left with a positive term at the very end. And then all I need to do is I just need to plug back in. So I have natural log of, this is a u, so I'm plugging back in for x squared plus 1 plus 1/2 1 over x squared plus 1. So when I write out my final answer, I take this natural log of x, so I have a natural log of x minus 1/2 natural log of x squared plus 1 plus 1 over 2 x squared plus 1, and then I write a plus c at the very end. And looking at the answer key I have, that matches exactly. So we've arrived at the final answer. Natural log of x minus 1/2 natural log of x squared plus 1 plus 1 over 2 x squared plus 1. Now keep in mind you could pull out a 1/2 if you wanted to from all these terms. On a free response, the final answer is much more lenient, so don't waste your time doing unnecessary algebra and unnecessary steps like that. This is a perfectly acceptable answer. So we have arrived at the final answer, and free response 2 is solved.
The Teaching Center, UF's Learning Resource Center.